Brisk technology. Brisk stands for Binary Robust Invariant Scalable Key Points. This is a low computational feature detector scheme known to provide better performance than SURF with comparable accuracy. Looking into the mechanism, it starts off with the scale space key point detection mechanism. Then you see sampling point Gaussian smoothing, followed by pair generation, gradient computation, then descriptor generation. And you see these right here on the side, which I will soon explain. Starting off with the candidate interest point detection mechanism. IPD uses AGAST, which is adaptive and generic corner detection based on accelerated segment test. That's a long word, short AGAST. This is a corner detector mechanism. AGAST is an extension to FAST, so it's an improved FAST mechanism. AGAST uses circular symmetric pattern region shapes with 60 point pairs. AGAST uses point pair line assignments arranged in 4 concentric rings. Scale space key point detection is based on scale space using octaves and intra-octaves. These are created first. Then each octave is half sampled from the previous octave, and intra-octave is downsampled to be placed in between octaves. Scale space key point detection will then use non-maximal suppression on each octave and intra-octave. Subpixel maximum is computed across the patch, and continuous maximum is computed across scales. This here is the scale space key point detection mechanism that is used in Brisk. Sample point Gaussian smoothing is also applied. The Gaussian smoothing is applied to the patch area around each sampling point. The red circles represent the size of the standard deviation of the Gaussian filter, like in right here. You see the red circles, which indicate the standard deviation size. Pair generation is then conducted where point pairs of pixels are separated into 2 groups. There are long segment pairs used in coarse resolution. There are short segment pairs used in fine resolution. The short and long segment pair separation is used in scale invariance processing. Gradient computation? Well, a gradient is computed on the log segment pairs first because they're trying to determine the feature orientation. And then comes the turn for the short segment pairs. So the gradient is computed on these to determine the amount of rotation in reference to the orientation, which was determined by the long segment pair gradient processing. Binary descriptors is made from the rotated short segment pairs. These are the references that I used, and I highly recommend them to you. Thank you.